Production of electromagnetic waves or radio waves. All electric and magnetic fields arise due to moving charges. Our problem is to know the conditions where these fields would radiate away from the source from which they originate. Now, electric charge at rest gives rise to column field around the charge which is stationary in space. A charge moving with constant speed is equivalent to a steady electric current which generates a magnetic field in the surrounding. These fields also do not radiate. Hence, we should expect radiation only when the charge has accelerated motion. When we accelerate the charge, we do some work and thereby supply the energy which can be propagated out in space in form of electromagnetic waves. Thus, we know the condition that an accelerated charge radiates energy. For the production of electromagnetic waves, we have a simple generator of electromagnetic waves as shown in the figure 16.2, where an antenna is formed by two metal rods connected to an alternating source of potential of frequency. This source is known as a oscillator having wave shape of the potential as shown in figure 16.2. So this is so much. The oscillator causes to flow back along the antenna. The system is showing at several times in cycle after start. Negative charges have been pushed to the end of the upper rod and an excess of positive charges remains on the bottom rod. At the time that is 1/4 of a cycle later, the charges have come back together again and the rods are momentarily uncharged. Since later at the oscillator has reversed polarity and the charges are reversed with the top rod positively charged. At any one instant, say, we see that the electric field surrounding the antenna is similar to that due to a pair of equal and positive charges. At point P, for instance, the electric field is upwards, but half a cycle later it is downward. During the time positive charge is flowing the antenna from bottom end to the top end, the upward current produces a magnetic field, and the right hand rule tells us that the lines of induction of the magnetic field are one of the form of circles. At point P, the magnetic induction is perpendicular to the plane of the paper, directly horizontally away from us. Later, while charges are flowing back down the antenna, the magnetic induction B reverses direction but is still horizontal. Thus, we see that at P, two fields coexist and that the E field and the B field are perpendicular to each other. And the P wave is propagated horizontally broadsides on the rods at a point such as Q. The magnetic induction is zero, head-on view of the current, and hence no wave is propagated along a direction parallel to the length of the antenna. This is how the wave model explains the propagation of energy by radiation, as electric and magnetic fields can exist in vacuum, and hence no medium is needed to transmit energy by an electromagnetic wave.